Why are we in my garage today? Well, we are in the garage because I need to get a ruler. We're going to be looking today at how far the planets are from each other. We're thinking about it in terms of relative distance. We say that because we're never the same distance from the sun. We're constantly rotating in that sort of circular motion, but sometimes we're closer to the sun, sometimes we're farther from the sun. So we're kind of approximating, that's the relative distance. If it was an absolute distance, that's how far something is from a set point at all times. So this is relative distance. We're in the garage because I need something to use to figure out the distance so we can kind of be a little scientific about it. So I have a lot of different rulers in here. We're gonna take a look at those rulers right now and try to figure out which ruler is the best one to use. This is a T-square. It's used to hook, and you can measure the left and right, and you can also measure perpendicular. But this isn't going to be great for long distances because we'd have to keep repeating this size. So I don't think this is the ruler of our choice. This is a 90-degree angle or triangle ruler. It does have numbers on it, but we're not looking for angles or 90 degrees, so we don't need this one. This ruler, I'm not sure of the name of. It's great for multiple angles or resizing, and you can adjust it any way you want it, but we're not doing odd shapes. So don't need this one. This is one I picked up at a garage sale just because I thought it was neat looking. Again, 90 degrees. We can hook it on a side so we know it's not going to slide. We can also do a straight line with it. It has numbers. It's hard to see because it's older. Not going to help us because we're going to repeat this a lot, and we don't need an angle on the ruler. We also have a tape measure up here, great for long distance. I don't have somebody to hold the other end, and I would have to keep checking it. So I'm not going to use a tape measure for this one. I keep it in a different drawer just because it's easier to get to, and I use it a lot. Wait, this guy here, this is what we're going to be using. Got it. This is just a wheel ruler, just as simple as that. You roll it along and the numbers change. It goes forward and back. The black is feet, the white is the inches, and this is great for long distances. Probably see this used for road work, or somebody had to measure a field, or for a sporting event. This is our choice. All right, so I'm walking down to an area in my neighborhood where I'll be able to draw, and I want to tell you what we're drawing on the pavement. So like I said, we are drawing how far the relative distance, how far the planets are from the sun. And again, it's relative because when we're orbiting the sun, we're always at different distances. It's not always the same. We're going to be doing 9 planets. You heard me right, 9 planets. Pluto is one of those planets, and it's kind of like a question. What came first, the chicken or the egg? Is Pluto a planet? Is it not a planet? Scientists are constantly trying to figure that out. When I grew up, always a planet. Wasn't even a question. Then I got a little older and they said, Pluto is not a planet. And then they said, it is a planet, but it's a dwarf planet. So that's kind of important. What is a dwarf planet? Well, a dwarf planet has substantial mass, and it orbits the sun as well. What changes in it, a dwarf planet, is sometimes when they're in orbit, they bounce out of that sort of elliptical circle. Sometimes they bounce out. They're still in orbit, but they don't have a steadfast path that never changes. It'll change on occasion with a dwarf planet. So we will include a Pluto today in our drawing. Wanted to let you know there's about 4 or 5 other dwarf planets. One is not discovered yet. It was discovered in 2007. And until those scientists decide on a name, it just goes by a number. Another interesting fact. Okay, I'm almost there. Have to cross the street both ways, and we'll be drawing. All right, so it's always important that you have all your materials. So I have my chalk. I have our measuring wheel that we talked about earlier, and I already drew the sun. So we want to be a little scientific about this, right? So wherever I'm going to start my measurement every time from this line right there. So you'll see that line. That's where I'm going to be starting my measurement from. We want to start at the same point so we have the same distance, or every time we go a little bit farther, we know it's in relative aspect to that sun. So that's where we're going with that. Let's start. I don't think we have anything else to do. The first planet that we're going to do is Mercury, and it's pretty close to the sun. It's only 2 feet away in our drawing. Let's check it out. All right, so I am done with the drawing. I don't know if you noticed how far away I appeared, but it felt that far. And today I feel like I'm on the sun. I know we're nowhere close in that temperature, but it sure feels that way. The temperature of the sun, that's a whole nother video. It is about 94 degrees out here right now. So we're gonna just take a little walk. I'm gonna walk backwards. We're gonna see how far these planets appear. And I think that should be it. We'll also probably take a picture of each one, and I'll probably edit that with my little walk. So here we go, the walk of the interplanetary relative distance. And again, remember, that's to how it's orbiting, and we included the dwarf planet. So we have 8 planets plus a dwarf planet. That makes 9. Here we go.